Hello everyone, welcome to yet another stream. So today we're gonna be making an operating system. So we're gonna be following the OS Dave, and hopefully we're gonna do it. Okay, so yeah, let's just start. In this tutorial, you will write a simple kernel for started bit x86 and put it. This is the first step in creating your own operating system. Well, let's read the beginner mistakes. I mean, I'm kind of a beginner. I have made an operating system before, but you know, I'm surely that it wasn't good. The code base, and yeah, it wasn't good at all. So difficulty is beginner, so it should be pretty easy. So yeah, I think we all got everything for sure. I think even came up, but I don't know how to use it. I think it was like x86 64. I mean, yeah, surely it has some common, but I'm just not sure how. Putting the operating system to start the operating system, I just need basically. Okay. The software will be needed to load. This is called bootloader, and in this tutorial you'll be using grub. Writing your own bootloader is advanced subject, but it's commonly done. You'll later configure the bootloader, but operating system needs to handle when the bootloader passes control away. The kernel is passed a very minimal environment in which the stack is not set up yet. Virtual memory is not yet enabled. Hardware is not initialized, and so on. So I guess I'm gonna use grub for this one. Hello chat. Okay, cool. Alright, so alternatively you can use nice and much your assembler. What does the tutorial use? Booster assembly. I have Nasen. Set align loaded modules on the page boundaries. Bro, this thing is confusing. Where do I even start? Okay, I also have to talk this, I believe. No. Okay, so I don't. Implementing the kernel. As far as you have written the bootstrap assembly stuff, let's say the setup processor such that high-level language such as C can be used. Is also possible for other language such as C++. Freestanding environment. Okay, let's check out this code first. So say align other modules on the page boundaries. So we set the main info, provide memory map, like magic. It's a magic number. Let the bootloader find the header. Oh yeah, I have heard this. I think it was like 512 bytes of data on the header, so the BIOS could find the bootloader easily and check some magic plus flags to provide their multi-boot. Okay. Declare a multi-boot header that marks the programmer's kernel. These are magic values that are documented in multi-folder. The bootloader will search for the signature for the first 8 kilobytes of the kernel file line at the 32-bit boundary, the signature in its own section, so that header can be forced to be within the first 8 kilobytes of kernel file. Okay, so I guess we're good. Section multi-boot, okay. Create section called multi-boot and outline for long magic, long flags. Okay, I don't even know what these are. Called in assembly. So let's check what is long in assembly. A directed that is assembler to a simple 30-bit quantity right here. The disassembler typically means this when data. Okay, so it's just like integer, but you know, larger, I suppose. Okay, yeah, just like C++, you use long, and so on. I knew. Okay. Skip 16384. This gives 16 kilobytes link. The linker thread specifies start entry point to the kernel. In the below we jump to this position once the kernel has been loaded. It doesn't make sense to return from this function as the bootloader is gone. Bytes link. The linker thread specifies start entry. Yeah, I was just checking. Sorry if that bothered you. My bad. I just had to check. Okay, so I suppose it should sound good now. Yeah, that'll be it. The bootloader has loaded us into 32-bit operating mode on x86 machine. Interrupts are disabled. Paging is disabled. The processor set is defined in the multi-boot standard. The kernel has full control of CPU. The kernel can only make use of hardware features and any code it provides as a part of itself. There is no printf function unless the kernel provides its own stereo.h header and printf implementation. There are no security restriction, no safeguards, no debugging mechanisms. Only what the kernel provides itself. It has absolute compile power over the machine. Oh my god, this thing is hurting my eyes. No, not repeat. Stylish, please. Please. I don't even know how to use. Also, we might need a VPN, obviously. Okay, so we call the kernel main, which is I don't know. I don't even know where to start this thing. It's so weird. So this is how you write the kernel, the following blah blah blah. This kernel uses a VG text mode buffer located at 0xb800 as the output device. It sets up a simple driver that remembers the location of the text character in this buffer and provides a primitive for adding a new character. Notably, there is no support for line breaks. And writing the character will show some VG specific channels instead, and support for no scrolling when the screen is filled up. Adding will be your first test. Please take a few moments to understand the code. Important note, okay, so the VGA text mode as well as the BIOS is deprecated on newer machine, and UEFI only supports pixel buffers. For forward compatibility, you might want to start with that. As a root setup frame buffer using appropriate type of flags, or call Visa VBE. I don't know what that is. It's a video mode. Yeah. Oh yeah. It is. Give control info. So this is the one that says the RVF supported video modes. So we can get to Tommy Marty and okay, here's how it's like in assembly. Okay, very good, I guess. I don't know where to start. Header text mode, color constants. First of all, study bold definition integer. If the file Linux you are not using cross compiler, you will not tell the run in trouble. This tutorial will only work with 432-bit or IX86 target. Okay, I mean, it works. I've got a 64 PC, plus I'm not gonna run it like on the bare machine. It's gonna be running on the Kimo compiler. Starting line, new integer, unsigned integer, 8-bit, VGA entry point, VGA color, and VGA color for background. Okay, that all gets modern and I don't know how to pronounce minimalistic or something. Just you get the idea, the minimalistic looking UI. Yeah, it is so basic. Reads with 80, right 25. So for every string we increment the length variable. Yeah, minimalist, not minimalistic. Okay, so the VPN changed my, what is this? Language changed to English. So it's terminal row, terminal column, and terminal color, and lastly terminal buffer, VGA memory. Terminal initialize for terminal row, column, and color. VGA entry color, VGA color like gray and black. Okay, so it's a lot. I thought I had this installed, but it's just like yeah, might run into a little issue. Wait, so like, can I taste it now? So like, is this gonna work? Let's see. Cool. We don't have this, so I'm gonna be using Nasm, but I don't know how to use. Nasm, but it's more right. Okay, so there are a lot of errors. Yeah, I heard that Nasm uses a different thing. So like, I don't think it's the same thing. Maybe I just installed whatever this is. I thought I had it installed. I think I do, but I don't. Come on, work. Come on. Oh gosh. I've been streaming to myself for the past 10-ish minutes. Bruh. Oh god. Oh my god. It is so slow today. Oh wait, think no, still no. Bruh, this thing is so fucking slow. I'm so fucking tired of this. Okay. Show more, no. Please don't refuse to. Oh, come on, bro. This thing is very slow. Wait, I'll be right back. back. I don't know what's causing the internet to be slow, but yeah. Fedora. Excuse me, I'm Fedora. Huh? Oh, my bad. I have GCC. I mean, I had them. I'm not sure, but yeah, I think I did. Wait, let's ask the AI. GCC. Yes, we got everything. Yes, we do. Oh, maybe not this one. We got this one though. Here's GCC version. See? Oh, come on. What? That's it? Hopefully it's not that big. We're following like a decade old, over a decade old forum on Stack Overflow. Hopefully it's gonna work. I686 86 DLF tools. Then see it has something. What? No, it's Fedora. Yeah, it's Fedora. Oh, hey. Are you making your voice? Oh, no. It's a little bit. Yeah, it's a little bit. I'm following the tutorial, you know. And it says 32 bits, so I mean, I think 64 bits are like kinda harder to make. Yeah. But something is going on, I don't know. I just have to install the compiler it uses. but I don't know. Don't ask me why I'm using AI. So it should work. Okay, let's follow the steps. I think I have this installed. Maybe not updated though. Okay, yeah, also not my Fedora is not updated, so you know the database returns 404. So maybe it's worth trying GC with. Sure. Yeah, so like I'm not that expert. I don't know much, so maybe that's why I'm just trying my best to try to install this compiler, you know? So we said GCC with mserito, like mserito this way, like files. Boots.sm to, I don't know if it's gonna work this way, but boot.img. Yeah, I don't know how to use this. Just this way, okay. Maybe it's worse. Probably. I took it from iOS. Okay, wait. Just see. I'm sorry. Oh yeah. Usage. Among the most widely used compilers today, resources are therefore C++, Objective-C, Objective-C++. Bro, I'm asking for the usage. Wait, AI mod. I think from iOS. Okay, dude, I'm so stupid. Like, what am I even doing? Bro. I wish I could go for this one, but no, it doesn't work for Fedora, just for Debian based Linux operating systems. And I think I gotta install this one because I already have this one. Yeah, so Fedora, GCC, GC++, CC, C++. What? So you probably need to compile with ASM with NASM maybe. Yes, I do have. I do have to do that. So like I tried. Oh wait, no. I forgot how I tried, but yes, I did. Here I found the way how to compile. So I tried it. You know, that's what everyone does, but no. I heard that like NASM requires, or like it's more straight. I don't see any not label thing here. I don't know why it's failing, but I heard that something like label, not like this, but label and something. Because I was trying to compile another OS there that was built on Windows and they just didn't want to. Still installing. Wait, how about I ask an AI what the fuck is this code? Like what the fuck is wrong here? Label or instruction is pasted at the start of the line. Warning, improperly calling multi-line macro sect a line with 0 parameters. Yeah, I think it's worth asking Gemini. So I wonder if the stream is lagging, because I feel like internet is not as fast here. It's pretty much fucked up, but you know, it just does the job. What? Wait. The numbers you're seeing in your boot.sm file is our files are strongly indicative of an incorrect assembly file format for the NASM assembler or potential issues with the way line ending were handled when the file was created or transferred. The most common cause for specific error site error level blah blah blah. Incorrect line ending, the most likely. Wait, I think it would work if I try to use this one though. But you know, I gotta go along with the tutorial. It will work this way. And yeah, I don't know how to use Kimo because I don't remember. Just a podcast did. See, it's just that it's more specific or like strict. Literally enough, nothing to do. See, it was all installed. It's just this one, so yeah, nothing to be crazy for. Export for face, vibrate something today, I swear to God. So what it does is this prefix as home. Target, yeah, the compiler, and it has the prefix binary with the paths, and yeah, we created a directory at the prefix. The source code. I'm just doing everything at this point. Just doing everything, bruh. For a foreign font. I knew it. I fucking knew it. It's fine, bro, don't worry. What the heck, bro? I've built an operating system before. I'm pretty sure it's on this exact same operating system if I didn't break it. Hopefully. Let's just bring it there and check if it does. So I believe it's in the document. I don't know. Could be learning the OS empty. I don't know. Literally, I don't know what it is. Probably not in the project here, so probably not on this machine. Plus, wait. You're still here. Sorry for my accent or like my grammar in general. I know it's not good, but I'm working on improving it. So, yeah. Hopefully you understand what I'm saying. How to install? Oh, it says food. So, what do I use to install? Because I have everything that I don't know, bro. I'm so confused right now. So do the install. I was about to say my password out loud. Oh my god, I'm so dumb. Okay, now it's not available. I don't know. Let's maybe ask ChatGPT. I'll do this so it doesn't show my history. You know, you gotta act smarter sometimes. Sorry, I just choked something because I was eating like minutes before, and I literally couldn't breathe. 3 for 30 days. Why not? Pricing this is gonna take me somewhere else. Surely. Let's open it here then. No? Okay. Yes, sure, I said yes. Oh man. I forgot to mention that I'm on Fedora. Activate your trial. Yeah, sure. She wants my MasterCard number. I can put that in. Because why not? Okay. Yes, I want 64 bit, but whatever. Oh my god, that's kinda big, not practically big, but yeah, it's kinda big. Oh yeah, no, it's not installed. Yeah, so like, you're gonna have to wait a little bit. Stripe. Okay, let it load in. I'm gonna pay upstream, you know. Not upstream, but I'm gonna hide it. Oh gosh, I'm gonna have to wait 5 to 7 minutes. That's slow, like very slow. So let's just see how it is till then. Here's an hosted environment. If you have done C or C for programming in user space, you have used this so-called hosted environment. That is external libraries for other functions. .h. Oh wait, it thinks I'm from Ireland. No. Okay. Yeah, I'm gonna do that now. So as it continues to download, I'm gonna purchase a free, or like you could say it, a free trial. ChatGPT. Yeah, so guys, let it download here. It's downloading. You know, see, no, see, 17 fucking minutes. No, but anyways, yeah, I'll be right back. Let me pay for ChatGPT free service. If I'm very good, I don't wanna show my face, so I'm gonna lean. Good. I'll be right back. So we're back. And how did it go? Failed. Why? I don't know, I said my character was declined for some reason. No, it wasn't. Just some weird shit, you know. Anyways, hopefully you're still here. Hopefully. So you're robbing OpenAI. Not robbing, but technically they gave it off for me, so yeah. And they took it away. They didn't wanna give me. They didn't wanna give me the free plus membership. Yeah, man. It sucks. It really sucks. Oh my god. Okay. So I've been streaming for like 39 minutes and you don't even have the compiler installed. What the fuck? Okay, maybe hopefully soon. %. Yeah. Okay, so I don't know why I'm feeling down, but okay. It's almost there. Nearly. Like 78 kilometers. 1430. Fucking hell. 933. Bro, that is so slow. I pay for like 600 kilobytes per second. shall we? Oh, I gotta like have to get like grab. Oh come on. Hopefully it's not that big. Okay. 9, 4, 3, 16, 35, 33, 38. Bro. 3, 2, 1. There you have it. Let's go. Okay, cool. So now let's try. No. Let's try compiling the correct code, which is this one. What? What the fuck? Bro. I just installed this one. You also, right? You also, you have seen me installing it. Oh yes, I did. Oh my god. Hopefully it's gonna work. What do they say? What? Oh my bad. File format not recognized, treating as linker script. Okay, I don't know. Gosh, I hate this thing. No. Yeah, let us just let ChatGPT say, because I don't want to waste like I don't know, forever trying to install the compiler. Bruh, are you fucking kidding me? Like, I installed a lot of things. Is there any alternatively? I can give you much faster if you already one liner installed that should get, and without only building everything, it's much simpler. Sure, I mean, why not? Let's see what it is. Then let's install spare parts. Huh? What? Maybe this does exist now? This looks practically simpler and easier, and actually faster. But I don't know how big it is. Most of the compilers are kinda big because they contain a lot of things, but still no, it doesn't exist. Okay. Okay. And I bet it's responsible for a fall. Well, I didn't bait, but I didn't. It's wild. Yeah, it is. Like, it's very specific. Oh my gosh. Wait, I gotta check something. Yeah. Okay, anyways, I'm not arson off anyways. So, what is the widget? What? So today's stream wasn't as smooth as the others for some reason. By the way, if you're wondering, I'm eating right now. Bruh. Oh, come on. No, that doesn't even exist, bruh. I've tried it, didn't I? Okay, I think there are. If I'm bothering you while eating, I'm gonna mute my song. viewer here. Yo, how are you? Okay, it's very bomb, I guess. Look, this website is so fucking it's so fucking weird and fucking confusing. I don't even know how I'm gonna continue. So it shows this is how I do it. Non-NASM compilers, but for the NASM one, it's short and it's here. You see. Class membership. Yeah, it sucks. I know, see? Oh my god. This thing is stressing me out. It's stressing me out. Look, it's gonna hit the white thing. And the video will end. I think I know that. Bro, how am I supposed to read this thing? It looks so much better like this. Then when I scale it up, boom, it sucks. my food. I was so focused on the food that I forgot to watch the video. My bad. Yeah, this thing always confused me, I remember. I don't know what it does, but you know, it is what it is. Alright, cool.
In this case, the instruction is DB0 stands for find byte 0. And this is the number of times 1 to execute. Two dollar signs represent the beginning of different sessions. So this is the length of the previous code. Since we have code to be 500 kilobytes long, we'll need to add 510 minus the length of the previous code to get to 510.
Wait.
The instruction is DB0 stands for find byte 0.
DB adds 1 or more byte to the binary code.
And this is the number of times 1 to execute. Two dollar signs represent the beginning of different sessions. So this is the length of the previous code. Since we have code to be 500 kilobytes long, we'll need to add 510 minus the length of the previous code to get to 510.
So it's like 18 minutes, it's the same shit. This is gonna be 15.
Which adds up to 512. When we add the two
Yeah, I think I said this. Really that,
what we want to do with this file is make it into a binary of this. In the future, if there's some information we'll get as the same software. What we will
good.
do now
Yes, because I'm gonna be using that as well.
This one creates the binary file. This one must be wait.
So supposedly it should work, you say.
That means working. Trying to change the final number as a chat.
I mean, obviously it's gonna work because I've done this thing before. Okay. And now it's failed to boot. Booting from floppy not available disk. Well, it sucks, doesn't it? That sucks. It's kinda cozy watching video with you. Huh. Well, it also sucks that I've got a slow internet, so it's like, I don't know.
This is what I work. Next episode, we'll learn how to print.
Well, right, mine didn't work, it failed. So like, yeah, we had junk in the dollar sign 8 times. We subtract 510 from the dollar sign, DB0 and DB 0x55 and 0x88. Wonder why it fails. So like, I did everything correctly. I remember that this thing worked before, I think, but not now. What could it be? Because I see nothing wrong in this code. It's literally the same. Literally. The jumps, everything is the same. Maybe it's worth asking the AI. Because I mean, of course I'm not gonna comment for the dude. Bro, I see what you're doing. This is classic biosector stop. Let's break down. What guys, if you did the stars, that's 5 for milliboard and passing up to 50 bytes. So the dual authentic the current address and the double authentic the second section, that's correct. We need to take a share, which is also correct. So where's my style with address? Oh, yeah. I have had an issue before and I think this thing fixed it. Oh no, I gotta compile it first. Instruction parse what? I think it was like this. No? So it's like protection mode, I think. I used instead of both red by the is conventional and sure cell better than the other day. So like in our case it doesn't even compile on. It's not like Kimu doesn't treat it, but it doesn't even compile. This is kinda confusing, I'd say. Even if I copy the whole code, it won't. Let's see how he used down. He shows the command arguments. So F that's a little bit, and I can't quite tell, but it seems like BLN or binary just VIN. F and is BLN or BIN. If it's neither of those. Yes, it worked. Hooray! Okay, so yep, they put it. It worked. So it was. I think it was the way how we were compiling it. I suppose. I think it should work now. Yep. It was the way how we were compiling it was 34 bits and not binary, which failed to load. So we gotta find that in chapter 2. So is it counted as like making my own operating system or copying someone's operating system? Could be either.
Part 2. The first lesson showed you how to write very minimalistic setting. This one will talk about BIOS, and at the end of this video, I'll give you a bit of a challenge you have a way to solve. Oh, by the way, quick note. Before you go, why BIOS, why not UEFI? You are absolutely right. This method is not possible to one, but I think it's best for you.
Bruh. Yeah, it was 2 times speed, main goals of this series, showing what's underneath the surface of language like C to give the best better perspective to games in students.
To make you reach levels or something like that. So yes, one day you'll be preparing code real mode. You should do 16-bit mode assisted by something called BIOS.
Yes,
BIOS stands for Basic Input Output System. This is a system that provides you with simple tools you can use to say display characters on screen, input characters from the keyboard, read from this fullest description. This is where we left last time, an empty everlasting loop. Let's use BIOS to add something. This time though springs out the alphabet. The first thing you want to learn is how to bring characters on screen. Programming assembly is a bit like pushing buttons, controlling switches, and connecting wires. When you move value from a register to another, you are physically connecting those registers to each other. To enter a particular mode, some register must be in the right value, just like switch or some machine would have to be in the right position. Same goes with BIOS routines. Bring the character on screen with first name to switch to outside mode. To do so, use the AX register. First of all, we want to move using the move instructions to spend less time. The hexadecimal number 0E into AH.
I can't quite tell what it is, but maybe let's have it better, you know. Yay! Yes, it booted! Hooray!
Then when the character wants to bring to
move AH. Please get the fuck away. Please, bruh. I beg you. Bruh, get the fuck away from my face. Let me type that shit. I think it says move HOXOE. I don't know what it asked me. I think it's worth writing, isn't it? Forgot what it was at, but I think it was more to the LAL register and it was OXOE and it was the AE, what? No, AH registration because like I've never heard AE registration, CPU registration, yeah.
Finally, we want to build something called a BIOS.
So we're gonna...
is a response by the processor to an event that needs attention from the software. Whatever operation CPU is executing, if you're interrupted, can do something else. There are many interrupts that do many.
Cool, BIOS interrupt. Yeah, I remember some shit, you know, it's coming together.
And different things. The one to print using BIOS is hex10, which we'll call using the INT instruction. If we repeat this seemingly tedious process a few times, we can even print a whole sentence.
So we all put them on AL. I guess that works. Let's think it's like this. Int O times like yeah it is. I remember there was a way to put everything in one, so the OS could easily read it. Like I remember using like DB. This is not B, this is O. Pointer. Let's see if this can work. Kimu. Hooray! No pointer. Let's go. It worked. I guess so.
Save it, and use the commands described in the previous lesson. Let's now have a closer look at a single character. To represent an ASCII character, we use single quotes, but it's only one of the many ways we can do it. Let's have a look at an ASCII chart. The letter A is represented by decimal 65, which is hex 41, and binary 10000001. If you print these three values, we'll end up with 3 A's. What if we wanted...
Wait, where do I get... Okay. Hexadecimal... or ASCII. Okay, ASCII. Yeah. That'll be it, I guess. There is a photo here, but I prefer the website version if there is. No. Yep. So like I'm not gonna write everything like this, but you know. So I don't care. So AL it could be 78, I guess, and it will still work. Yep, and it could be, what is it? 40, and no, 40, and it still works, doesn't it? No, it doesn't. Maybe like, no. 40, still no. There's no such a thing. Maybe like, maybe this way. Oh yeah, it is. So it's 41, 42, 43, 44, 45, 46, 47, 48, 49. Actually, it's very easy, bro. It starts from 41 for alphabets, and it goes on since hexadecimal starts 16, and the index contains from 0 to 9. After every integer it gets to alphabet until F, because that's what hexadecimal supports. Alright, so shall we? No, I'm not gonna fucking count here. No, there's no way. Yeah, oh wait, yeah, it's otherwise. Why not? So like we're gonna do it by ASCII, alright? I don't know, I'm just gonna make this space. And for this one, O is 4F, so. And S, I suppose, S is like 53. So it should work. Yeah, we did. There you go. This shit is easy as fuck. I don't know, bro. This shit is like easier than, I don't know. Let's see, my friend.
Yes, we might do that by printing each and every letter, but look, they're all right order. We could do something like this. First of all, print the letter A. We could keep the decimal value, or just write A like this. Maybe if we keep the decimal value, you will understand better what I mean. If after this we print 66, and then 67, we print A, B, C. There is a way to automate this process. After we move 65 into AL, it will stay into AL even after the interrupt, so we can use a command to increment AL. This command is inc. It is equivalent to sum AL1. It simply adds 1 to AL.
Oh,
so
yes,
these two lines, we can print some of the alphabet.
Increment.
But there must be a faster way, right? Like with a loop.
What? Wait. So we have a registry AL and we increment to AL.
That's
How
one.
does you know
AL.
what
Just repeating
we
these two
want
lines.
to increment? I mean increment means 1. Okay, but we don't ever tell it to draw anything. This is weird. Okay, wait. Let's get rid of everything. Right, till here is fine. So yeah, we don't want this as well. So do we run an H or AL? Okay, we don't need H though. So AL is gonna be 65, which is A, and increment AL. And that should work, I guess. Should be A, B. Yeah, because it just increments 1. But if I repeat the process, I'm gonna select until F or something. No. So yeah, GH. Alright.
You can print some of the alphabet, but there must be a faster way, right? Like with a loop.
Oh yeah, we jump to the loop. So if you also wanna like print, I think 64. I'm not sure. Maybe. Oh no. And 65 prints B. Okay, so it's glad for me to see that the stream is stable on kind of like 60-ish FPS. I don't know what was wrong,
Okay, do you see the problem here? It's
but it's good. So yeah, we're gonna have like wait, no, this is not WPA here. Yeah, so in the loop we have got these two, and we jump to the loop until I don't know, we do something here. I don't remember. I think it's gonna crash after quite a while. Oh, so it just keeps going because we don't increment anything. We increment what we have. No way. Increment A. B. Maybe if you have this outside. Yep. I wish I could pause and see what is going on. Oh my god. Dude, how do I kill this thing?
Try running something very weird will happen. If only there was a way to access the loop. And of course there is one. Let me introduce you to conditional jumps. In this new program, I move 4 to bx. I want to check if bx is 5. As you may tell, it is not. There is an instruction that compares two numbers by calculating their difference. The C and B instruction. These are the possible outcomes of this comparison. And for each of these, there is a conditional jump instruction. A jump instruction that is ignored if its condition is not satisfied. The one we'll use today is JE, jump if equal. This is an example. This is an example. A jump instruction. These aren't. There is an instruction jumps. In this new program, I moved 4 to bx. I want to check if bx is 5. As you may tell, it is not. There is an instruction that compares two numbers by calculating their difference. The C and B instruction. These are the possible outcomes of this comparison. And for each of these, there is a conditional jump instruction. A jump instruction that is ignored if its condition is not satisfied. The one we'll use today is JE, jump if equal. This is an example.
Okay, so remember what it means jump if L means less than, G means greater than, E means equal, and all. Good, I mean it's actually really simple.
If the value of the bx register is equal to 5, then this program will jump to the label and print x. If it is not, it will just jump forever and print nothing. Let's try this one out. Since bx is 4 and not 5, it prints nothing. But if I set bx to 5, it will print x. Back to the alphabet. We need to compare AL to Z plus 1, which is the same as 90 plus 1.
Nice.
If the content of AL is equal to Z plus 1, instead of printing the value, it should jump to another label, the exit label, where it will jump to the current address indefinitely.
What? Wait.
Where it will jump to the current 90 plus 1 to print x. Back to the alphabet. We need to compare AL to Z plus 1, which is the same as writing 90 plus 1. If the content of AL is equal to Z plus 1, instead of printing the value, it should jump to another label, the exit label, where it will jump to the current address indefinitely.
Z plus 1 means like, let's see what it is. Z, not small letter, it's 90. So 90 plus 1 is 91. Compare AL, Z plus 1, what? So like, if AL is 90, which means it reaches after the Z, it should exit the loop. Shouldn't proceed, I guess.
And sure enough, here it is. the alphabet. Your challenge when I summon.
Duh. It's not easy, hard at all. You know, I can do it. I don't even have to look at the tutorial, you know. So I just gotta put it there. AL will start from 65. Increment. Wait, I gotta look at it. So yeah, we increment AL. But where is it? I should go a little higher so I can see better. I guess I'll just put it here and increment AL. No, AL. And so we compare at AL the integer z, or simply 90 plus 1. So if it's correct, and there you go, then we're gonna jump to exit. If not, we're gonna proceed, right? Jump label, and we need something like exit. Okay, should work. Yep, it did, but it started from B, means something's wrong. 64 should bring A. Yep, now it works. Hopefully my stream is still smooth and steady. Yeah, it seems like it. Just have to bring Discord here. Alright, cool. So, thank you, bro. I wish I could react. Yeah, this is for you. And the stream is nice. Yeah, I can feel that. Assembly is easy as its core. Yeah. Wait, I didn't see that. Oh. First of all, I pinned that by accident. Second of all, I can keep that there. And third of all, I didn't even see that. Yo, I was about to miss that shit. Glad I pinned it by accident. Okay. So, actually, I'm just copying the tutorial, bro. I'm doing nothing.
And sure enough,
I'm ashamed of
here it is,
myself.
the alphabet.
There is
Your
no
challenge when I
color,
summon
there
is
is no
Make a
nothing.
program that outputs the alphabet in alternating caps. Good luck with that. Share your results in the comments. See you next Sunday.
String keyword input in BIOS.
Today we're going to learn how to print strings and get keyboard inputs using BIOS routines. With these goals in mind,
Yeah,
we'll learn a very
actually,
simple approach to the use of
this
variables
guy
in the cell.
Not
Once you
having
see how to print the alphabet,
tutorials, you
it's an
know.
exercise to print the alphabet in alternating caps. As a result, you know.
No, I'm not gonna sit like with this type of shit resolution. Okay, that video does not that much. But it does the job, doesn't it? Oh, it's done, I didn't even know.
I don't know how to use loops to print a series of characters.
Bro, I actually really thank you for sitting and watching the whole damn stream. Wait, let's see if it's gonna work. If not, if it starts buffering anytime, we're moving on. Oh my god, typical driver issue. Yeah, I guess changing the resolution will fix it. If not, at least reloading the web page.
That's pretty much how you print strings. You surely know that. The characters of the string are memorized in continuous cells. The idea is, pretty much as you can see already, we have a pointer to the beginning of the string, we print one character, we increment the pointer, we print again, then increment the pointer, and so on. The thing is, with the alphabet, we know when to stop, because we
Yeah. This thing is pissing me off, literally. I know my drivers are not updated, but bro, it should work. I'm not gonna like risk trying the driver.
No character is repeated, and the last character is predetermined. How do we possibly know when to stop with other kinds of strings? You might know that strings are null terminated or zero terminated. That means that at the end of every string appears a null character, represented by the number 0. We can just use that null character to check if we're done printing the string. The other big question is, how do we memorize the string? Well, we know that when we load our program, the binary image of the file is loaded to memory. You have surely heard the phrase data and code are the same thing, which is one of the foundations of what's known as the von Neumann architecture. What that sentence means is that we store data.
Yeah, it's gonna stop. It gets too close to the white. Oh my god. What the fuck is wrong with this video
The very same way that we store code, as code is just data that happens to be executable. To keep things clean, we usually separate code and data by putting them in different segments of the memory. We'll talk a bit about segmentation soon, but for now we are just putting it all together.
Okay, now I put it in, it doesn't play. Does it? No. Yeah, the difference are speed and this kid's skill that. But it doesn't play, look. Yeah, I see why.
We are just putting it all together. As you know, for
This
the
thing is really slow. Oh my god. Yeah, I guess you're gonna go for
first lesson, every instruction is translated into binary code by our compiler.
Oh gosh. Wait, what really got stuck? No, it's not playing, see? Why?
There is
Dude,
one pseudo instruction that allows us to write to the binary file directly, the db pseudo instruction. db can be used to set a single byte of our binary code this way, or more than one byte using commas. Since ASCII characters are 1 byte long, we can also define characters this way. Also, we can define sequences of characters by using the string syntax. And we can mix the two. Let's use db to define a string and print it. In order
okay, how am I supposed to read that?
to know what memory cell will contain at the beginning of our string, we need to assign its name. We can do so by adding a label just before defining our string.
Well,
Then we can define our
that's
string,
just
making sure to add a null character.
combination of colors. Can't read shit.
At the end. To print the first character, we need to initialize delta mode, as usual. Now, we need to move the first character into AL. Variable name is effectively a
So initialize the age for it to be drawn. I'm not sure, I mean the text buffer is yes, that's what they call
pointer
it.
to the beginning of the string. So in order to access the
0x0e. Yeah, everything's set it out. We just gotta remove this one. ALV
for this character, we just need to do a reference
variable
pointer.
name. What is the string? Label the string. What is 0? Label variable name. Oh, okay. This is a variable. See?
This can be done using square brackets. This should print the first character of our string, but this is not a B, is it? Well, turns out that memory addresses are not counted from 0, but are offset by the hexadecimal number 7C00.
What? 7C00. Well, let's try. It's worth trying, isn't it? think variable. Start looking at the YouTube. See, I think it's DB and hey or like no the pointer 0 and if we compile it manually, we're gonna see R. Duh. So maybe as you said, we need 7C. I think it was called the rotation mode. No, I'm very wrong.
Why this number? I'm not sure. To compensate for the offset, we could add hex 7C002.
Yep, now it's just the N. You can guess what the rest of the word is gonna be. It's either good word or bad word.
Well, a pointer, but an equivalent way is to set the origin of a memory addressing by using this command. As you can see, the character B has been printed correctly. From now on, if you apply the very same idea we used to print the alphabet,
Yes, exactly my point. Auric 0x7CR, and I think we are safe to remove it from here. And no.
as you can command. As you can see, the hex 7C002 a pointer, but an equivalent way is if you apply the very same idea we used to print the alphabet, as you can try to do right now by posting the video, the result shouldn't be much different from this one.
Oh, so the whole thing is there. Alright, good. Now it doesn't even show the end. So here we have the R30870. Remove the H to OXOE and it's BX. Oh my bad. To the variable, and the variable has what? Where is the fucking variable? What is that? But we're gonna see you now. Yes. Print string.
What I'm doing here is I'm simply
Put the full on the hill.
command to the pointer, stored in BX.
Okay, I mean let's try that. Plus we don't want to exit either, do we? No. Also, we don't wanna yeah. So move by base variable, and yeah, straight to right the bottom. Hey, Sekuwa, hey, welcome to the stream. It's me just trying to build operating system from scratch. Obviously, I mean, what else am I gonna do? But you know, print string. So we move to BX. So at the end, we wanna call jump, and what was it? This. Right. Okay. Let's see.
And printing single characters until the pointer reaches the null character. Printing a character from the keyboard is not much harder, as there is no device function with that very purpose. What you need to do is to set AH to 0 and trigger interrupt hex16. As an output, you get your character in AL and a byte scan code in AH.
Wait. AL is a key character in the H scan code. What? So it's like an input.
If we want to save a single character to memory, we can define a new byte1 variable initialized with 0.
Maybe.
Then we can set its value to the value of AL. As you can see, we can still use square brackets to reference the pointer, and the move instruction to set the value of the memory cell.
Wait.
Scan code in AH. If we want to save a single character to memory, we can define a new byte-long variable initialized with 0. Then we can set its value to the value of AL. As you can see, we can still use square brackets to reference the pointer, and the move instruction to set the value of the memory cell. If we wanted to memorize a whole string, we could use a buffer. We could implement it by just defining an empty string of whatever size we like, and write the characters in the memory cell, pointed by, say, bx. To do so, we want to set bx to our label, which makes it pointer to the beginning of our buffer.
So like we're writing the bx to the buffer. What is bx? What the fuck is going on?
And then we want to move AL to the buffer.
Wait,
So we
I need
reference
someone to
we can
practically
put this in a loop and make sure not to exceed the size.
help me practice this thing because bro, there's no way
If
I'm
you want,
gonna
we can try to
understand
write a
this
procedure
shit.
that memorizes input string and prints it back. And if you like, we can share your solution in the comments. In the next episode, we're going to talk about the stack, functions, and something called segmentation.
What? No, the pointer is prints out, but why? Print string, we're calling print string. I don't see us calling yes we do, but where do we even call this thing? Where? Wait, if I take that. See? We don't even call it. So does that mean it gets executed no matter what? Oh wait, I forgot to compile. Okay, so now it works. Just like here, just for the sake of it. Alright, so I'll open this. Maybe let's proceed.
I'm fairly confident you know what the stack is, but just to make things clear, I'm going to make a little bit of a push. The stack is a part of the use memory one or two times a which.
Let it chill, let it chill. Bruh. Oh. What the fuck is this?
So, the other one is called dates. There are only two operations.
Where they encode the video, bro. It sucks. It literally sucks. Like if I jump, it's gonna load the whole fucking thing.
Like from the top of the stack.
When you pop a violin from the top of the stack, you remove from the top and assign to the register like the code push 6 pop X has the same effect as. Oh, so why would we use this way than this way?
There is a classic analogy with a pile of dishes. One can insert or remove a dish only on and from the top, and this block using the breaker. And sure enough, one could easily remove a dish from the middle. Pop. Let's try to write a program that uses the stack. I'm sure you will immediately understand why it's useful. So first things first, we
No, I didn't understand why it's
want to
useful.
initialize our stack. This is done by setting a pointer to the base of the stack and one to the top. Okay. We can do so by setting two special registers. The base pointer BP and the stack pointer as P. We can set the base to hex 8000 for now, and we can use the same value for the top, as the stack is now empty. Let's set BH to whatever value we like, and push it on the stack, using the instruction push BX. We can now modify BH and print its value. Alright, nothing special yet. We just print the last character we set BH to, but if we use the command pop BX and try to print again, then we should print the previous value of BH, the one it had before we pushed it on the stack. I suppose you see when we could use this. Suppose that, say, the value of the register AX is very important and you don't want to lose it, but you need to execute a procedure that is going to change it. One thing you could do is push it on the stack, do your thing, and retrieve the value later. A couple of very useful instructions are push A and pop A that push and pop these 8 registers. Let's now imagine this scenario. Our program
I
is doing
have
something.
no fucking idea what's going on.
Probably something remarkable and exciting, like, say, printing a string, I guess. To do so, it has to set some registers. Suddenly, our program has to execute a procedure, so it pushes the registers not to lose their values, jumps to the procedure, does its thing, gets back home, pops the values, and goes on with the program. Sounds familiar, doesn't it?
No.
Procedure, so it pushes the registers not to lose their values, jumps to the procedure, does its thing, gets back home, pops the values, and goes on with the program. Sounds familiar.
So like, push A. What are you doing here? What's the purpose of the push A? And pop A. So like, does it clear what was pushed onto the A before and after it's done the procedure it gets jumped to after the procedure variable and now it gets popped. That's how it works?
Doesn't it? Sounds a bit like registers not to lose their values, jumps to the...
Oh my god. good. I mean, I knew it. I knew something would be fucked up. You know what? I'm gonna disconnect the VPN, but it's gonna leak my fucking IP. Dude, hide that shit. It's not my idea.
I'm fairly confident you know what the stack is, but just to make things clear, I'm going to make a little bit of a push. The stack. To do so, it has to set some registers. Suddenly our program has to execute a procedure, so it pushes the registers not to lose their values, jumps through the procedure, does its thing, gets back home, pops the values, and goes on with the program.
Lost the value twice, like if push makes it lost the value, then how would we pop it for still to lose the value, like it doesn't have the value anymore.
A bit like how functions work, right? A function is a part of the program that can be called, and at the end of which we can return to the execution of the instructions following the call. Luckily, that mess is not the only way to implement functions. We could rewrite the code by simply substituting jump with call, and the return with RET. The stack is going to be handled automatically. You might have noticed that the structure of this video is itself based on push and pop. In the description you'll find a link to the brilliant piece of literature that gave me this idea. As promised in the previous video, we're now going to introduce segmentation. In real mode, we're working with 16-bit addressing
Oh come on.
under 36 bytes, which is 64.
Not 16-bit addressing. To the power 16, yeah.
4 kilobytes. That's not a lot, and we would really like to be able to reach a larger part of the memory. For this reason, we introduce segmentation. Segmentation divides the memory into segments, each up to 64 kilobytes long, so that we can reference the whole segment. The segments we care about are the data segment, the code segment, and the stack segment. For each of these, we have a segment register. DS is the register associated with the data segment, and for the other two, we have CS and SS. There is also an X register that we will use in the next video, but for now it's not necessary to talk about it. Of course, the physical address of a memory location inside one of these segments can be well above our addressing limit of 64 kilobytes, and this is where the segment registers come into play. To represent a memory location in, for example, the data segment, we use a combination of the value of the data segment register and a 16-bit offset value. In particular, the absolute address of a memory cell in the data segment is equal to ds times 16 plus the offset. This operation is represented with this notation. Both of the values we use to calculate the physical address are 16 bits long, and at the same time, part of memory reach rises by 16 times, becoming a bit more than a megabyte. So that's the solution to our initial problem. One thing you might be thinking is, why do the data, code, and stack segments have these names? Well, as I briefly noted in the previous video, it is sometimes very convenient to separate data and code, so we might want to put them in different segments. It should not surprise you that instructions are in the code segment, data is in the data segment, and stack is well in the stack segment. Most operations we counted already did in fact hide the presence of segmentation. Remember when we printed a string? We had a pointer to the first
Oh my god. I think I'm gonna watch the video on my phone. It sucks to watch it there. Yes, it does, it sucks. But you gotta fix these shits, bro.
is well in the stack segment. Most operations we counted already did in fact hide the presence of segmentation. Remember when we printed a string? We had a pointer to the first character of the string. Since the string is data, the pointer is not a variable name, but ds offset by variable name. The thing is, ds was 0, so the address really was just a variable name. Also, remember we had to set the origin of the memory addressing to 7C00. Well, turns out that another way to offset the memory by 7C00 is to set ds to hex 7C0, since hexa. C0 times 16 is in fact hex 7C00. Also, as you might imagine by now, when we were using the stack, the actual address of the base pointer was not simply BP, but rather SS offset by BB. Considering how little time we're going to spend in real mode, what I've done, what many others have done in their previous projects, is to use the so-called tiny memory model, in which we set all three registers to 0. We'll talk about segmentation again.
Let's see if I understand anything from here now. Or it's just... Okay, so it doesn't show us anything about the loader here itself. Grub. Yes, grub. What's next? I don't know, I'm just gonna click everywhere.
I'm fairly confident you know what the stack is, but just to make things clear, I'm going to make a little bit of a push. The stack is a part of continuous memory model. We set all three registers to 0. We'll talk about segmentation again a couple of videos from now, just before starting to write our kernel. Now I'm leaving you another couple of exercises. Try and write a function that brings a decimal integer number, and use it to print the value of yeah.
I don't like watching videos. I prefer text mode, but I don't know. This thing isn't for me. What is it? Wiki. Yeah. Could not also it shouldn't it's not specifically just website. It could be yeah. I think this one is the one I want, but it's worth checking on every of them. So maybe they've said it's down. Yeah, most probably. It's not my internet. I mean, I'm not gonna blame my internet for everything. Okay, about the boot, the reader created contributed change license. See the programming language has to place the build system which will change BIOS the bootloader. There we go. I think that's it. Okay. Linker, what? Okay, oh, I should start again. License. Select and start with the channel. The different story will be a separate language. CBCC be used because developing analysis requires a very precise control of generated code and directed to the memory. Other languages that provide the same features can also be used, but this build will only cover C. So no assembly. Yeah, I mean obviously it's gonna use their real PC. I mean I'm smart enough. Oh yeah, I personally don't know what BIOS is. Okay bro, this thing is really light. Okay, anyways, compiling the pin stem, the parameters, the readiness of the code since serious language is available on the chapter. Getting it to C, tribes how to set up. Getting to see what? Yes, I will show you. Do you see some assembly class running with the assembly? Yeah. Gotcha. So, compile device. The entry point of the ELF magic number. Okay, I've seen this before as well. Define the magic number. Constant multi-boot flags and calculate the checksum. Text starts the start of the text code section. The code must be followed by the line. Write the magic number into the mission code, the flag, and the checksum. The loader label defined destination point in language script. Place the number OXCAFEBABE in the register EAX loop forever. Sure, it's gonna work. I'm not very optimistic about this. Like I can't lie to you. So this is the code, right? Oh, wait. It works. Both failed, many failed. Yeah. Because we don't tell the BIOS how to exactly do things, Maybe it's message file directory. So this should be called loader. Wait, why not I stop? Why not do I say? I said something. I think. No. Loader at all. And it's the same thing, bro. Okay. So now we're working on the loader. Making the kernel. You don't even have to see code. Entry loader. Bottom of the entry level. The code should be loaded at 1 megabyte. So this tells what 1 megabyte is, I suppose. There. Trace the line. I'll line up with my audio section for all files. Okay. Align up with the line, all read-only data section for all files. Data align data section for all files. probably not for covering to comment section from all the files, so there will be a section from all the files. Okay, so like literally so that's right there. Name of the entry, yeah, there you go. It's a loader section, it's a 1 megabyte, a byte, 4 gigabytes, yada yada. Hopefully we have memory at least, yep, we do. Kernel live. Cannot open linker. Oh, I call this linker. It's worse already, but I'm gonna go for this one. Here's the second tutorial. So now we can kernel to the left, I suppose. But not below this. Okay. Building ISO. The grab version we all use is. Oh, so we're gonna be using grab. Still, let's get to specific. Okay, so like, do I have to specifically download this? What? Open TPLE, it just download. Oh gosh, it's gonna open the browser. Yeah, I know. They be doing everything. Maybe if you just open it this way, it's gonna download. Yep. Oh, it's actually not that big. The configuration does not work with Ubuntu, so there you go. Copy the files. So look, I'm not on Ubuntu. It's Fedora. I mean, not the automation, it's Fedora. They barely do. What? MP4? Wait, oh, MP4, my bad. I was like, fucking what? So like, here you have grab. So the ISO image can then generate on system using the grab legacy and grow to more specifically the grab legacy or stage 2 something. Yeah. Building ISO this. Oh wait, first of all. Okay, so now building an ISO image. The executable must be placed on the media that can be loaded by a virtual or physical machine. In this book you use ISO image files with the media, but one can also use floppy images depending on what virtual or physical machine supports. So we're gonna create this, copy the bootloader. What? Okay, so my eyes are hurting for okay, so like it starts with S, I see. Stage 2. Stage 2 what? Concert or something? Oh my bad, I shouldn't be looking at that. Stage 2 electro. Stage 2. Let's go back. What if I am not on Ubuntu? But yeah, I guess I just do. It'll do, but I don't know. Is it a folder or what else? Where did I? Oh. Duh. So kind of understanding what's going on here. think I did. I saw build grab. So still doesn't exist. Okay, it says I should use W gates, but probably it's gonna say horror. Oh yeah. Or even better. If this thing is bigger than like 100 megabytes, then we're gonna continue the stream next week or tomorrow. So it's already installed. Okay, CP kernel body to put. Alright. Oh, okay. So where did it do that? I saw the boots. I thought it did, but I don't see anything. See, I saw. Let's see, boot. This. Okay, there we go. There is a kernel body on there. Create groups in alright. Here. Group with CFG. CFG. So there's a timeout 0 minute. 3 ways one type with quick and relay. Alright. Alright. Someone found I knew it. Oh. Oh boy. Oh gosh. Yes, it is why it's not unified. For sure. Is there anyone in the stream right now watching? Anyone? Just say hi or something so I know that there's someone still watching me. Just 10 megabytes. Oh, that's not that much. And you can download with like I don't know, just quickly. Alright, so since it's a BIOS, we might also have to install the modules. It says. Okay, it's already installed. So, but still says the same thing. What's wrong? Yes, it didn't install that all. What? Like, I just did what you said, what you wanted me to do. Like, do you want me to check? Sure, I guess, I don't know. No matching package to list, no. It's not installed. Bro, how many things? I'm installing whatever things you say you want me to install. And it's already installed. Real life sucks. Oh, you're still here. I thought you wasn't here. I thought I was like touching with the wall. Like, you know this meme. Yeah, I thought I was like this, you know, talking to no one. Glad to see you here anyways. Thank you. I really do appreciate it. I don't know, I think I'm just gonna let ChatGPT figure it out, bro. It is getting weirder and weirder every time I run a new comment. What? Bro, what? What? It says failure shit. See overrated. Maybe this is blank. Oh my god, rap. Nowadays, 4 files I didn't want to confine as image, boot image. Pass. What's going on? Okay, maybe this is gonna work. Nah, bro, I'm only listening. Thank you, bro. I mean, this stream is boring as fuck unless you wanted to listen to the Minecraft soundtrack, and it's even annoying because there is no voice. So let's just say it's gonna take a while. Let it download and we will continue the stream tomorrow, hopefully. So it was nice today. I don't know. I have no like actual thing like Saturday. That was it. Bro, I don't even know what to say. Do I just say bye and quit the stream? I have to be polite as Japan's, alright? Oh, I'll learn this with the most dumb way, you know? But whatever, mostly it's like trial and error, that's why. But that was it for today, maybe tomorrow or next week. So hopefully that was a good stream. Even though there was only a single viewer, the rest of them were like, yeah, on and off, on, off, on, off. you know, sometimes it goes like spike and off again. It gets to the point where it was 0. Still, the student was spaced out. Yeah, thank you. And that was it for today.